Alright, so today we are going to go through 1-3, which is on negative exponents. Our learning target is to simplify expressions with negative exponents. So if you remember, we had two rules for simplifying monomials that we've already gone through. The first rule is the product of powers. So this is the one where you're going to add the powers. So if you have the same base, like a to the m times a to the n, they both have the base there of a, you can go ahead and add the powers together and combine those as one. So you can go a to the m plus n. So the example there is 5 to the third times 5 to the fourth. So you can add the powers there together. 3 plus 4 there is 7, so you get 5 to the 7th power. Then the second rule for simplifying monomials is a power of a power, where you have a to the m all to the nth power. So in that case, you're going to multiply those two powers of m and n together. So you end up getting a to m times n power. So the example there below is 3 to the fourth, and all that is to the second power. So then hence you went ahead and multiplied 4 times 2 and you got 8. So it becomes 3 to the 8th. And then you can go ahead and write that number, whatever that value is, and simplify it even further. So now let's go ahead and look at a third rule for simplifying monomials. So if you have 1 over a to the negative n, what happens with that is you can move it to the inverse side. So that means it's down there right now, down in the denominator. We're going to move it up to the numerator and make that a to the n power. All right, so when your exponent is negative and it's down in the denominator, you can move it up, that power with the base up there, that base there, and you can move it up and make the power positive, so it becomes a to the nth. All right, so then over there on the right side there, you see 1 over b to the negative 8. You can move that b to the negative 8 up, and it becomes b to the 8th. So b to the 8th over 1 is just b to the 8th. So then our other one there is what happens when the negative is up in the numerator. So you have a to the negative n. Well, you can move that down, so the inverse side, so it's down up in the numerator, you're going to move it down to the denominator. So then it becomes 1 over a to the nth. So it becomes a positive power when it gets down in the denominator down there. So the example there is 2 to the negative 3. It's equal to 1 over 2 to the third. And then, of course, we can even simplify that even farther. So that becomes 2 to the third is 2 times 2 times 2, which is 8. So it becomes 1/8. All right, so another rule for exponents is called the power of 0. So if you remember, anything to the power of 0 equals, what would that be? 1. So since that's true, this says 5 to the 0. So my solution there is 1. What happens if you've got a variable to the 0 power? It's also 1. All right, so what about the quotient of powers there? The quotient of powers ends up being where you got, like for example there, a to the m divided by a to the n. Well, if you remember when we had a to the m times a to the n over multiplication, we went ahead and we added the powers there together. Now when it's over division there, we're going to go ahead and we're going to subtract the powers. So hence it becomes a to the m minus n. That's a subtraction sign there. So in other words, down here you've got 4 to the third divided by 4 to the second. We can change that to 4 to the 3 minus 2, which becomes 4 to the first, which is equal to 4. So let's do another one here. Let's do n to the 5th over n to the 3rd. So when I do this, I just subtract my regular numbers. There's 5 minus 3 is 2. There's more up here in the numerator, so it becomes n to the 2nd. And you could put it over 1, But if you put it over 1, it just becomes n to the second. What would happen if we had it the other way around, like n to the third over n to the fifth? Well, again, you're just going to subtract your powers. 5 minus 3 is 2, but there's more down in the denominator. So your n to the second is down here, and because it's down there in the denominator, you need a placeholder up here, so we're going to put a 1 up there, so it becomes 1 over n to the second. All right, so let's go ahead and let's simplify some of these. We've got 3x to the negative 5, all divided by x to the fifth. Now the 3 there, it doesn't have any power attached to it, so the 3 is going to stay up there. It's not to the negative 1 power, so you're not going to change where it's at. But that x to the negative 5, it's going to flip down here into the denominator. So you already had an x to the fifth down the denominator, and now that x to the negative 5 flipped down there with it. So now you can use your product rule there and go ahead and add the two powers down there together. 5 plus 5 there is 10. So we get 3 over x to the 10th. Then letter B here says 4x to the fifth all over 6x to the negative 2. So I'm going to go ahead and just rewrite this correctly. The 4 doesn't have a negative power. It's x to the fifth up here. That's not a negative power. The 6 doesn't have a negative power, but down here it's x to the negative 2. So we're going to flip that up and make it x to the second. All right, so let's combine our x's up there. Since it's over multiplication up there, we add the powers, and we get x to the seventh. And now we can go ahead and reduce down that 4 6. So if I reduce down the 4 6 there, 2 goes into 4 there twice, and 2 goes into 6 there 3 times. So you can either write this as 2/3 x to the seventh, or some people like to do 2 times x to the seventh all over 3. All right, so let's come down here and look at another one here. So we've got 32. X to the negative 6 is going to flip down. The 20 doesn't have a exponent, so I'm not going to do anything with that. I'm moving the x to the 6 down here because it had a negative power. X to the negative 4, that x has a negative power, so it's going to flip up here and become x to the fourth. So now let's reduce down that 32 and that 20. I'm thinking 4 goes in each one of those. So 4 goes into 32 there 8 times, and 4 goes into 20 there 5 times. So really I've got 8x to the fourth over 5x to the sixth. Right? But I can still simplify those x's. I can subtract my powers here. 6 minus 4, there is 2. There's more down in here in the denominator, so 6 minus 4 is 2, so it becomes x to the second down here in my denominator. Alright, so now let's come down here and let's look at letter D there. It's x to the negative 6, and then it's over 8x to the fourth. Well, the 8x to the fourth, they do not move. There's no negative powers. But that x to the negative 6, I can flip it down and it becomes x to the 6 down here. And so I need a placeholder of 1 here up at the top. So if I combine the x's down there in the denominator, 4 plus 6 there is 10, so I get 1 over 8x to the 10th.